welcome again to the webinar series. As we're celebrating our 25th year of existence as the Nutrient Management Spear program, wanted to give a quick brief overview. This is a 2-page flyer of our program. It outlines what we're all about. For those of you less familiar with that, our motto is relevant questions and sound science for agriculture profitability and protection of the environment. We work specifically with dairy farms, livestock operations, and cash grain operations on improving competitiveness and profitability of those farms, while also maximizing environmental protection. We partner with a lot of people to meet 6 focus areas. They are listed on the screen here, 1 through 6, the land grant responsibility, soil health, climate resiliency, precision ag, dairy sustainability, on-farm research, and then student engagement and learning. The first webinar in the series was on December 5th. Focal point there was dairy sustainability indicators, with our dairy sustainability team within the NMSP in the lead of presenting. So that was part of the dairy sustainability focus area of our program. The third webinar in the series is going to be on February 6th, and then we will focus on working with yield monitor data. So we'll dive more in the precision ag component of our program. The webinar today is all about adaptive nutrient management, adaptive nitrogen, and phosphorus management. We will have one continuing education credit in nutrient management, and I'll share the QR code for that at the end of our webinar. I was originally planning to co-present here today with Agustin Olivo. He is a former PhD student in our team. And we worked on several of the slides for this presentation together. Part of what I will be presenting on here today is also a big component of his PhD when he was with us. He's currently a postdoctoral researcher at the University of Cornell. I also want to recognize up front that what I will be presenting here today in terms of adaptive management is a process that has been in place. It started actually in 2008. The original cast of characters that was associated with developing that in New York included Carl Zimmick and the Purdue program, Dale Gates with NRCS, Greg Albrecht with Ag and Markets, Jackie Lenderman at that time with DSC. The current group with the latest updates on our adaptive management approaches is now including Josh Orneski with NRCS replacing Dale. Sarah Latessa with DSC replacing Jackie, and then Ron and Brandon joining the Ag and Markets crew, and Kirsten Workman, who joined us several years ago in Carl's old position. We work very closely with an advisory committee that includes a lot of stakeholders, and research reflected here today will also include the work of many of our current and previous teammates, students, postdocs, graduate students, and undergrads and staff. With that, I'm going to start with a little bit of history. This whole thing of adaptive management started in 2008. At that time, a group of folks from NRCS at the federal level, Environmental Defense Funds, Iowa Soybean Association, and universities under leadership of Tom Morris at the University of Connecticut started conversations about adaptive nutrient management as a process that could help in context of the 590 standard, CAVO connected NRCS 590 standard. At that time, a description was released of adaptive management by NRCS, and it's called a process for evaluating and adjusting nutrient management based on data collected at the field level following a set of protocols. A group of folks came together, including the original stakeholders, but many other universities and many other stakeholders joined under the header of NERA 1002, a multi-state committee, multi-state group, exchanging ideas about how we could develop something related to adaptive management as a way to advance nutrient management within the 590 context. The definition of the NERA group was it's an ongoing process of developing improved management practices for efficient production and resource conservation by use of participatory learning through continuous systematic assessment. And the participants included producers, service providers, policymakers, regulators, scientists, other interested stakeholders. Key in both of these statements is the idea that you make a change, you implement a different management strategy, and you evaluate if it made a difference. NSCS at the federal level released Tech Notes 6 and 7 in 2011, and then 2013 replaced 2011. And with that document, we were able to start putting something in place for individual states. That is the documents we picked up here in New York, started working with, and said, can we do something here in New York that makes sense, that's effective, efficient, and that we could implement here in conjunction with the 590 standard for nutrient management. I'm going to cover two components, nitrogen and phosphorus. Most of the webinar today is going to be about nitrogen, but I also have a little bit of information about the phosphorus index and the adaptive management option within the phosphorus index as well as we move forward. So I'm going to start with the nitrogen part. Nitrogen, adaptive management for nitrogen, was first released in New York in 2013 by means of a series of fact sheets. The first one was to just describe the process that allows farmers to adjust management over time while still complying with the 590 nutrient management standard. And the description in the fact sheet is that a successful adaptive nutrient management process requires careful planning, multiple years of investment that can lead to improvements in nutrient use efficiency over time. This is in recognition that maybe it's not just technology that we need to advance the way we can manage nutrients, but it's also the process itself. We had two fact sheets back to back. The first approach to nitrogen management options was to take the original ideas of the 2011 and 2013 NRCS document and focus on the implementation of nitrogen rate studies and the use of the cornstalk nitrate test as a way to identify when enough is enough, when nitrogen rates can be dialed down again. So in our fact sheet 72, it says that if CS&T's cornstalk nitrate test results from a second year or higher cornfield exceed 3,000 ppm for 2 years, then we have to start reducing that and manage it below the 3,000 ppm limit. This interpretation was based on a lot of field work that we did around that time. And these interpretations here based on the science. It says excess, more than 2,000 ppm, signaling that the plant had more nitrogen than it needed if the CS&Ts exceed 2,000. Knowing that there is variability within fields, variability in lots of things during the growing season, the partnership set the adaptive management limit to 3,000 ppm. And I have the links to fact sheets here. The original approach for the stalk test was to take them between 6 and 18 inches. 6 and 14 inches for an 8-inch piece of stalk. That's the original protocol. We also developed a protocol to sample after harvest. That is to take samples between 2 and 8 inches to facilitate the taking off the cornstalk test after harvest rather than having to walk through a standing cornfield. For more information on both of these protocols, take a look at the fact sheets. To give you a little bit of an update on typical numbers here, we are keeping track of CS&T summaries every year. You can find those on our website, but typically we are looking at about 25% in that excess over 3,000 category. With some variability in drought years, we give up yields and those numbers tend to be higher. As a result, in an extremely wet seasons, these numbers tend to be a little lower. Also a reason to monitor this for multiple years over time. Then in 2018, we added options. We had meetings with our advisory committees We still had the replicated nitrogen rate studies that were in the original NRCS documents and our earlier fact sheets. We also retained the CSNTs, but we added the option to do control strips in the field and use that as a way to determine whether or not the extra nitrogen beyond the recommendations was needed. And then for crops other than corn, we had an option to determine a field balance. For corn, we had the CSNTs. We could do the comparison. For other crops, we don't have a CSNT, so it was referring to field balances. The expansion in 2023 fine-tuned that a little bit in terms of the strips that were able to be implemented. So as you might notice, the list is growing. So we went from 2 options to 4 options where people could implement an enriched strip at planting and determine yield differences, or use the single strip evaluation approach to determine if there was a crop response or not to the nitrogen. And the same thing for control strips. On the webinar on March 6th, we will go into this in much more detail. So we'll explain what this C thing is, the single strip evaluation approach, and how you can use that for on-farm research and in the context of adaptive management. What I want to dive into here a little bit more today is the work that Agustin did with us. And that added the option to do a field balance for corn. In blue, you'll see here, determine available and field balances and manage at or below a 50% uptake efficiency and at or below 142 pounds available end balance. So what is an available end balance? This is basically a way to get around having to go back in the field and taking CSNTs. This is making use of data that were already collected or should be available from the nutrient management plan and the application records that would allow you to use those data to put a comparison in place between nitrogen removed and nitrogen supplied. The supply side has everything that we take into account when we do a nitrogen recommendation. Soil and supply, previous crops, any past manure history, current manure, and current fertilizer use, current year fertilizer use. The removal part is basically the amount of yield you got from that field multiplied by the amount of nitrogen in that yield. So nitrogen removal is nitrogen per ton of silage multiplied by the tonnage of silage that you got. If you have a field-specific crude protein number, you can use that and be most accurate. If you don't have that, we derived a couple of estimates based on work we did together with Joe Lawrence and the corn variety trials over the last several years. And these numbers are basically, if you have no further information, use 8.4 pounds of nitrogen per ton. If you know the short or long season varieties, we can go to 8.6 for the short season and 8.2 for the long season varieties. So you could use your own specific data for an individual field, or an estimate for the whole farm. But there's also some book values if that's the only way you can do this. There is a fact sheet that explains how to derive these balances, the available end balance, in much more detail. And the QR code here will get you to that page. You can also go to our website and look up fact sheet 125. So when we do these balances, there's 3 possible outcomes. There's the possible outcome that the inputs far exceed the end supply far exceeds the crop uptake. We supply a lot more than the crop can take up. Not a positive thing, not for economics, and also not for the environment. A second possibility is that we add very little and we export a lot, and through crop removal. That's a system that might work for a short period of time, but it's going to crash. So that's not desirable either. You cannot keep removing more than you put in. What is desirable is that we have some surplus of nitrogen supply compared to a nitrogen removal rate. That is, so more input than export. We don't want negative balances, but not excessively more. So how do we come to setting some limits there? And this is where we go to Augustine's PhD. Field balances, we're going to recognize that we have two purposes for those. One is at the end of season evaluation tool in adaptive management purposes, what I'm talking about so far. And I'll also share a few slides where we can think about these field balances more as a group of balances, so all the corn silage fields on a farm, to help set priorities for addressing excessive balances. We start with the end of season evaluation tool. So field balance is an end of season evaluation tool. Augustine worked with 8 farms across New York that shared up to 5 years of data. We had farms spread out from northern New York to central and eastern and western New York, cross-section across the state of New York. All were regulated CAFO farms. This database, so working with these farms and working through all the numbers, ended up with a full-size database of just under 1,000 observations. 560 fields included, a large number of acres included. So this was the basic database that we worked with. The framework looked at 2 indicators. So we developed a new framework, 2 indicators. There is an indicator that is called the balance. The maximum balance is the maximum tolerable N loss. This is the maximum amount of N that we think we should be tolerating. More than that is really a signal that there is too much of an imbalance between the supply side and the crop uptake. The other indicator we wanted to take along is an efficiency indicator that is nitrogen removed divided by nitrogen supply. So now we get a percentage. Nitrogen removed divided by supply. And we include in the new framework a minimum nitrogen utilization efficiency for corn solids. This is not a new concept by itself. There's some other research that we can tap into for similar type of approaches, but it made a lot of sense for us to go in this direction. This is the framework. This is where it comes together. So on the y-axis, we have N removed. This is crop yield multiplied by total amount of nitrogen in that yield. On the x-axis, we have the amount of nitrogen supplied with soil, with past credits, with rotation credits, with manure, with fertilizer. And we see 2 sections in this figure. The black line here is the 50% uptake efficiency line. This signals that if a point is, for example, here on the line itself, with the 100 pounds of available N, we cross over, we get 50 pounds removed. That means that we supplied 100 pounds and 50 pounds ended up in the crop. Anything that's below this black line is less efficient, lower efficiencies. We applied 100 and might have gotten 25 pounds in the plan. Right? The blue line is the balance line. And that we set at 142 pounds of N per acre. Maximum balance of 142 pounds per acre. If you're on the right side of this, your balance is higher than that, meaning you're exceeding this limit. If you're on the left side, like field 1, you are within the balances for both the minimum uptake efficiency and the maximum balance. F2 is outside, F1 is an example of a field that meets those criteria for adaptive management. So there's another fact sheet that outlines this, this particular approach and the figure that I just went through in much more detail if you want to see a little bit more how this works. The field balances by itself, individual fields, is a good approach to look at individual fields in adaptive management purposes. Adaptive management by definition is field specific. If you want to overwrite the recommendations for a field, you have to do the evaluation for that field. But with this approach, We don't need to go back in the field. We already have the yield data and we have all the records of that field through our CAFO approaches and planning. What that means is that it's much easier to do all cornfields on the farm and not just one or two. And that adds other benefits. So field balances can serve two purposes. We can also help use the field balances to prioritize cornfields for management interventions in future years. How does that work? So the same figure here, see the black line, you see the blue line, you have the red area or the pink area here that is outside of those limits. We added another area here in yellow between 69 pounds as the balance versus 142 pounds, signaling that if we can make that balance smaller, we do better. And then with this framework, we start looking at where fields land. Now we have to recognize one more thing when we do that with these interpretations, and that is the use of manure on our dairy farms and livestock farms. So recognizing total manure has both organic and inorganic nitrogen. Organic reacts like a slow-release fertilizer. We have credits in the year of application and then 1 or 2 years after that as well. The inorganic N is plant available N affected by the way we apply it and the method and the way we apply it and the timing of that application. And from our recommendation systems, many of you will be aware, if we can spring apply that manure and inject and incorporate when the crop is actively taking it up or close to it, just before planting, we can take manure credits. We can capture more of that nitrogen and take credit for that. So it's a more efficient use of nitrogen from the manure. The alternative approach, if we do fall application or we do a spring application, but we don't incorporate or inject, we cannot claim those credits. No manure inorganic N credits. So we recognize this with two new symbols in our adaptive management framework. The fields or the approaches where manure was incorporated at a time that a plant could benefit from it, in green, they get a green triangle. The fields that where manure was applied, but it was applied outside of the growing season or not incorporated, surface applied only, they get a brown box, a brown square. So let's go back to our figure now. Here is the adaptive management interpretation figure. We have 4 fields displayed here. The best scenario is field 1. Field 1 has a high manure use efficiency. It's a green triangle. We incorporated and applied it when the plant can take it up. And it also is on the right side of the line. It's in the green. It has a relatively low balance. Field 2 is also low balance, but we did not make maximum use of the nitrogen in that manure. We let the inorganic nitrogen escape. Okay. Field 3 did a great job with incorporating manure and applying it at the time that the crop needs it, but the balance is too high. So for field 3, a rate adjustment would be needed to move it to the left. The worst case scenario is field 4. We surface applied manure outside of the growing season or when the crop is not there to take it up and benefit from it. And we still have high balances. So that's the worst case scenario. We worked with 8 farms for this project with Agustin. I want to show some contrasts here. So farm 3 and farm 8. Farm 3 plotted all the fields where we had data for corn silage for. You'll see the green triangles, you'll see the brown squares. You also see some gray circles. Those are fields that did not get manure. They were farmed, they got fertilizer or they got nothing, but they did not get manure. Farm 3, the overall N balance was 41 pounds of nitrogen per acre, well below the 142 upper limit. 1% of the fields was in the pink area. In contrast, farm 8, the average The farm weighted average farm balance was 142 pounds of nitrogen per acre. And we see in this case 54% of the fields in the pink area outside of those limits. What we also see is quite a few here that have the green triangles. So manure was effectively incorporated and applied at a timing that a crop could benefit from it, the corn silage could benefit from it. But the rates were high. If we look at opportunities now, we can look at a different figure that puts this more in context for the farm itself and brings in the farm average yield. So now we have the achieved N balance versus the yield. And in blue is the English unit. So the yield, in this case, the average yield for this farm was around 20 tons per acre. The blue line is the balance limit, the 142 upper limit that adaptive management says you need to stay below. The black line is the farm average weighted yield. Now we have created a quadrant system with 4 quadrants. Quadrant 1 is plotted, if the field is plotted in quadrant 1, it means it has a yield that's higher than the farm average, of good yields, and it meets the upper limit of the field balances. It has a good balance. The worst case scenario is fields that are yielding low and have really high balances. Very often fields that plot in this quadrant 3 would be fields where nitrogen is not limiting production. Something else is. So we can use this to look at all the farm fields, the corn silage fields, and put together an assessment to help identify priority fields for some management changes. And this is what it looked like for farm 3. Remember, whole farm weighted average balance was 42, low balance. A lot of fields are in this quadrant 1 and quadrant 4. Just a few, 5% was in the pink. Farm 8, it was much more distributed among the quadrants, consistent with the earlier picture that I showed you for farm 8. What was driving this? Well, for the most part, it was driven by animal density. There is a picture here of all the 8 farms, animal density on top in English units, and achieved balances on the y-axis. Farm 8 had a balance over 1.4, 1.45 animal units per acre. Farm 3 is this one, had an animal density of roughly about 0.9 animal units per acre. With that, it is once again stressing the importance of managing the balance also between the amount of animals and the amount of land, and to figure out when manure export might be required. There's a new fact sheet we released late last year, fact sheet 132 on animal density. But the results from Augustine's work are pointing all in the same direction. The fact sheet on how to interpret this for prioritizing fields is on our website as well, and this is the QR code for that one. So the whole process, to wrap things up a little bit for nitrogen, adaptive management was by definition field specific. You want to overwrite the recommendations in a particular field, you have to do the evaluation for that field. And included having to measure yield from all fields that are involved in this process. It's a process of evaluating and adjusting over time, so measurements, evaluation protocols. In New York, we introduced it in 2013, following up on the release of the tech notes from NRCS at the federal level, with expansion of options in 2018. We added in 2023 the strip approach, the control strips and rich strips in 2025. The most recent edition has the field balances that I just presented on. Yields must be recorded for any field under adaptive management, just to recognize how important it is to have a yield measurement if you want to evaluate how well you're doing. It's very similar to wanting to know the milk production of your cow if you want to make sure that you know how well that cow is doing. All right, there's one level up that we added as a State of New York partnership to this adaptive management approach, and that's the recognition that if a farm can show at the whole farm level, then that is doing great with nitrogen management. Then we should still measure yield, but we might not need to do all these field-specific assessments. They do consume more time. The tool that we have in place to do this is the whole farm mass balance. Many of you are familiar with it. We take the farm, we draw a boundary around it, including animals and the croplands that supplies feed to those animals. And we look at how much nitrogen comes in terms of feed, fertilizer, animals, and miscellaneous things like bedding. Some farms are importing other sorts of organic materials. And we compare that to the amount of nitrogen that leaves the farm through milk, animals that leave the farm, crops that might have been sold, and miscellaneous. Miscellaneous for a growing number of farms is now manure exports. So total amount of nitrogen import minus the exports and gives us the balance. And then we express the balance in two ways, per tillable acre and per hundredweight of milk production. The hundredweight of milk production is an efficiency indicator. How efficient am I producing the milk with the nutrients that I import? The per tillable acre is more of the environmental indicator, and that's the one that connects us back to adaptive management policy in the state of New York. So adaptive management policy in the state of New York now says, if your farm has a 3-year running average of the whole farm nitrogen balance at or below 105 pounds per acre, that farm does not require additional field-specific evaluations. They don't need to do a CSNT or a strip, control strip, or an enriched strip, or a field balance for those fields. If they can show at the whole farm level, they meet 3-year farm balance of 105 pounds per acre or less. I want to give you a quick update, a little bit of a fresher from last time as well. You see in the picture here on the left is the current summary for 2024 so far. This number is going to change a little bit because we still get farms added to this right now. But the current weighted average whole farm N balance is 109 pounds of N per acre, just above that 105. All right. Our current CSNT assessment shows us that we still have around 25% of our stocks coming back in that over 3000 ppm category as well. So a lot of progress being made, but still room for improvement. And the hope is that these tools are going to help us move that forward. All right, that was the part on nitrogen. I'm going to switch over with some slides on phosphorus adaptive management. The screen says Northeast Region Phosphorus Index. You could replace that by New York Phosphorus Index as well. Similar approaches. Both of these have the adaptive management option in them. The phosphorus index, both for New York and the Northeast region, takes a raw score developed based on transport indicators, landscape indicators. A BMP credit approach, where you can lower your score by implementing beneficial management practices, such as incorporation, injection, applying to sod instead of bare ground, and things like that. That gives you a P-index score. And depending on your soil test P levels, that tells you whether you can apply manure or not. And if you can apply manure, whether it's limited to phosphorus removal or if it could be N-based, typically higher rates. The implications scheme is shown here. P-index scores. If the P-index score is very high, over 100, manure is not allowed for application on that field. You have to implement beneficial management practices to get that score down, to open up those fields. It's basically saying risk is too high. We have to implement beneficial management practices to bring that score below 100 to be allowed to apply manure. On the other end, if your soil test P exceeds 160 pounds per acre, Morgan test. Sorry about that. it exceeds 160 pounds. No manure either. What we did with adaptive management under the P&X context is agree that if a farm meets the whole farm P&X cutoff of 12 pounds per acre, that farm should be allowed some more flexibility. So if that per tillable acre phosphorus balance is 12 pounds or less, what happens is that our P-based limitations turn into N-based. So this gives the farm more flexibility. It gives the planner more flexibility as well. To give you an idea of where we're at right now for phosphorus, New York has done a super job bringing down phosphorus balances across the board. And our average right now is 5 pounds of phosphorus per acre, well within the green box, the blue box here. So a lot of farms are beginning to meet this criteria of 3-year running average, less than 105 pounds per acre. More and more people are participating now in our whole farm mass balances program as well, and we keep inviting people to join us. The new input sheets will be ready in probably about a week or so. The number of farms keeps growing. The 2024 data are not complete. There's still farms being added, and we're already beginning on adding the 2025 farms as well. So the adaptive management process, the idea is making progress through on-farm experimentation, through evaluation. It's a concept where we create freedom to explore, to experiment, to override the land-grant university guidelines, but with the responsibility to then do the evaluation to see if that higher rate was really needed. Measure yield is the basis for all of it. A lot of these indicators will require a measure of yield. And the adaptive management process is basically setting that as a baseline requirement. Evaluation tools now include the field end balances for corn silage. Balances are very easy to derive if you have the farm data. You don't have to go back in the field to take measurements. It can facilitate implementation of an adaptive management process, not just for a single field, but across the entire corn silage acres on a particular farm. The whole farm NMP balance assessments can give you insights into opportunities for improvement at the whole farm level and the field side as well, and demonstrate achievements and progress as we talked about in the first NMSP launch webinar series. With this, I want to open it up for questions. I want to leave enough time for questions here today. We have been focusing on nitrogen and phosphorus adaptive management for the obvious reasons of their connection to environmental protection and productivity on the farms. We will do our next webinar on February 6th with a focus on yield monitor data collection. And we'll continue to collect the CEU units for this as well. I was unable to monitor the chat, and I totally forgot to tell you to put your questions in there if you have questions. So I want to open it up for questions right now about either components of our adaptive management process before I show the CEU credits. Any questions? Feel free to unmute as well. Quiet audience. Does anybody want to speak up about experiences with adaptive management so far? Working with farms? Okay, thank you, Kitty. The system of adaptive management for nitrogen is set up, as you could see through the presentation, with the idea that if we come up with better ways of doing the evaluation, they can be added. So the list has been growing from just recognizing the importance of Cs and Ts as evaluation tool for corn silage to now including 5 different options that a farm could pick from. And as you noticed with the presentation also, it's expanded from being field specific for these evaluations to having a whole farm approach with the whole farm mass balance. I have on the screen here the social media list for our Nutrient Management Spear program. We have our website, newsletters that come out every 2 months, active on LinkedIn, and we recently also started Facebook and Instagram accounts. We have a YouTube channel that is beginning to grow with some more additions recently as well. If you go to the Nutrient Management Spear program website, you will see in the middle column there a way to click on this summary of our social media options and join us that way too.